After the hour, I think we can go ahead and get started. I'm Jennifer Kretschmer, the CRAN co-chair, the CRAN chair this year, I guess, for AIA Silicon Valley. Today, we're going to discuss tomorrow's technology is here, 3D printed structures. Our hosts are Emergent 3D Matthew Guile, founder and chief visionary officer. Over the last 20 years, Matthew has served in the business and nonprofit world on projects and initiatives ranging from founding 2 real estate investment companies and serving the Syrian refugees as humanitarian in the Middle East, and to serving as a commercial real estate broker, running university level development programs, managing FEMA-funded CAR fire disaster case management program. And that program helped hundreds of families recover and rebuild after the CAR fire. From his experience serving in those vulnerable conflict zones and disaster recovery areas, Matthew has decided to bring a solution to the housing crisis. And so he founded Emergent 3D. Emergent 3D is a construction company implementing cutting-edge technology to 3D print beautiful, resilient, and energy-efficient homes. He says, in the 21st century, with the technology and resources available to humanity, a global housing crisis shouldn't exist. So Emergent 3D creates homes in a fraction of the time of traditional construction so that everyone has the opportunity to live in beautiful, safe, affordable place that they can call home. Thank you, Matthew, for being here today. I'm also going to introduce Benjamin Albertson, who is the lead architect for 3D Emergent. He is a licensed architect and certified by NCARB, with over 20 years of architectural work experience. The majority of Ben's career, architectural career, has been under the auspices of 2 world-renowned architects, both of whom have won the International Architectural Design Award, the Pritzker Prize, and maybe he'll tell us a little bit more about that. The experience of working under these architectural masters taught Benjamin the unique opportunity to work in high-profile projects of various shapes and sizes all over the world. In addition to the valuable architectural training, he was able to experience different cultures and places that had shaped Benjamin's design approach and his belief structure that there is a unique design solution for every place and people. Ben believes that good design should reflect the character and identity of their people and place. And he has a master's degree from Yale University, a Bachelor of Environmental Design from University of Colorado, and he had received the top graduating student award from the College of Architecture and Planning there. Benjamin, thank you very much for being here today. I'm going to go ahead and hand this off to you guys to continue the presentation. Thank you.
Wonderful. Thank you, Jennifer. Let me see if I can successfully share my screen here. Are you able to see that from your side?
Yes.
Okay, wonderful. Well, Jennifer, thank you for having us, and it's an honor to be with you today. As Jennifer mentioned, I'm Matthew Guile. I'm the founder and chief visionary officer for Emergent 3D. I originally founded the company back in 2019. Well, I was in 2018. My family and I moved here to Northern California, to Redding, 2 weeks before the nationally declared disaster, the CAR fire. And so while serving the FEMA-funded disaster case management program and being in the middle of our community, struggling to figure out how we were going to recover after our disaster here, I had been watching 3D printing and decided to, in order to help our recovery effort, to found Emergent 3D. And I'm going to share a quick video with you from the first on-site 3D printed house in the state of California that was printed back in the early fall of last year. the volume may not come through clearly, but because I've had some technical difficulties, so just bear with me on that.
I'm Matthew Dial. I'm the founder and chief visionary officer for Emergent 3D. Here is the culmination of 3 years of work. It's a site-built 3D printed house. And so this is the first in the state of California. 3D printing allows us to build these beautiful organic shapes and do it at a very affordable way. It's an opportunity to look at, technology coming to everyday life.
We're providing affordable housing for our community members. What community wouldn't want to be the first at building something that would benefit community members in such a real and concrete way?
These houses will be marketed for families that are income qualified.
How we can build a structure faster. That's one of the main advantages of the technology. You can basically customize your house the way you want it.
We've got a $50 to $60 million capital expenditure program over the next 10 years. We are planning to put 50 to 60 of these printers to work all over the North State and the U.S.
It's exciting, it's the new ways and building technology.
So I know that I'm probably preaching to the choir here, but some of the main problems that we're facing in our housing crisis, and especially here in California, is our low supply of construction labor. One stat we like to share is for every 5 of the within the construction trades that are retiring, only 1 is coming in. So we are going to have by 2030 an 80% shortfall in our trained construction labor. And so this is a multi-decade crisis in the making. And so automated construction robotics is going to be one of the solutions to help shore up that massive shortage in labor. Also, the cost of construction is an obvious one. And then within the more workforce affordable housing sector, the cost savings versus the aesthetic design dilemma. With 3D printing, we truly can have on the design side our cake and eat it too. We don't have to forego a nice design to make it more cost effective. We are what you're seeing here is what we've dubbed our wildfire restoration house. Originally, this was designed to address the car fire recovery effort, and hence the name. It's a 1,200 square foot, 3-bedroom, 2-bath. You can see the coveted red stamp there in the lower right-hand corner. This is the first on-site 3D printed house designed to be approved in the state of California. And then also the result, we printed the first on-site 3D printed house in California. In partnership with the city of Redding and Access Home, the housing nonprofit, we are going to be printing a total of 6 of these homes here in Redding, and we have completed 4. And if it weren't for the atmospheric rivers that have been barraging our state, we would have already printed those, and these are moving forward with construction. This is the first one. This is in one of our parks called Enterprise Park for the city of Redding. This is going to be used for a park host. And so the city of Redding is providing subsidized housing for this caretaker to be on site, close the gate at night, and help the Parks and Rec services. And so this is, again, the first completed 3D printed, on-site 3D printed house in the state of California. And these are fresh off the presses, these images. Ben and I just went and took these pictures as of yesterday. And so it is rapidly nearing completion. This is the second one in another park here in Reading. The use case is going to be the same for a park host home. And this gives you a look at the stratified look before on the other one where we did a skim coat, because finishes are incredibly important to us, and we want these to be desirable, livable homes. But just to kind of give you a snapshot of before that layer goes on. And we had the honor to be able to print the first project in Los Angeles for the Woodbury University School of Architecture for their Department of Energy solar decathlon project. I think if I remember correctly, in the competition, there was about 20 universities competing, and Woodbury University won that competition and the premise was a net zero home, and their design was the only 3D printed design in the project or in the competition. And we went down, took our printer and printed it in 3 days. So it was a wonderful project to be a part of. And they are moving forward with construction, and I think they should be done with it in the next month or so. But just to kind of give you a look at the design there. Also here in Reading, this is in a affordable housing neighborhood. These are going to be 4 right in a row. And we have printed 2 of the 4 in this neighborhood. And again, if it weren't for the atmospheric rivers, we would have completed these 4. And so our company has moved out of the proof of concept phase and squarely into a full production phase. Here's a look at the 3D printer itself at scale. This one in particular is a little bit larger than ours, but to give you an idea of it, we can print up to a 3,000 square foot single story with 1 setting, or a 6,000 square foot 2-story building with 1 setting of the printer. We can, as Ben will take us through, obviously print larger buildings, but with 1 setting. That's the max print size of our printer, and this is the exact printer here. It is a modular system, so it can be scaled up or scaled down to match the scope and size of the project in the site. So that's one of the beauties of this technology, is that we're able to print on site and out in the field. We're not printing in a factory setting. One of the important points for that is it has been identified by Freddie and Fannie as a site-built home, so our clients can get a traditional mortgage on it rather than it going into the modular or factory-built lending category. And then also State Farm has identified our 3D printed homes, or excuse me, approved for their insurance policies, which is wonderful. So we're hoping to get many more insurance companies to recognize it, so that we can bring down the premiums for our clients. And I'll just race through here. It brings a solution to the cost of construction because as long as we don't wrap the walls in stucco or in drywall, we save on that time and material. And we're batching right there on site. And also with our low supply of construction labor, it's attracting a younger generation because it's a tech construction job. And so we're really excited to be able to help in that regard. And then also the freedom of design. And so that printer is going to be just as efficient on unique design number 1 as unique design number 10. And so rather than having a framing crew, design in such a way where they get their system down, that printer is just going to be just as efficient and do the quality control in the field every time. And so one of our objectives not only is to, as a company, to bring housing, but we want to use this novel technology to benefit as many of the stakeholders in the community as possible. And so we've partnered with CSU Chico and LIUNA, the labor union, in order to raise up the next generation workforce in this tech construction industry, and then also housing nonprofits like Habitat for Humanity and Access Home and others, as well as general contractors of plugging into the local general contracting networks so that it can benefit those economies and local communities wherever we go. And with I'd like to then stop sharing and hand it over to Ben from here.
Great. Excuse me. Thank you, Matt. Thank you, Jennifer, and thank you everyone for having us here today. We're really excited to explain the process of 3D printing to you all, and that's what I'm going to walk through for you is the construction document process, approval process for the wildfire restoration house that we did that's under construction now. We also have a church project, 6,000 square foot church project that's nearby here in Redding that has plan approval in Tehama County. That one hasn't started construction yet. So I'll show a little bit about that. I know this is the custom residential architectural network, so I won't spend too much time on that. I'll focus more on the houses, but just to get a sense of the variety of projects that we're working on and what's possible. And that's really what's exciting for me as an architect, is obviously the design opportunities that we can do with 3D printing. People see it, and I think even people that have had some experience with 3D printing, at small scales, think you can really do anything with that tool. But at the end of the day, it's still a tool. It still has its limitations. And so it's really important that we as architects, that we understand what those limitations are when we start the design process. We've had clients who come to us, we've already got this design ready to go, ready to start construction. Can you 3D print it and save us hundreds of thousands of dollars? That just unfortunately is not it's not that simple. We usually have to sort of redesign things. If you want to 3D print it, you have to really start from the beginning in order to best take advantage of the 3D printer capabilities. So for me, obviously the design benefits are exciting. The quality of construction is exciting. That we're able to provide a very durable product that has lower maintenance, especially here in California, which has forest fire issues. It has this inherent sustainability in the fact that we're rebuilding in a better way. It's still not 100%, fireproof, but it's at least, more durable. And then of course the time savings. And I want to, note too, and Matt may not like this, but we're still wrestling with the people see 3D printing and they think, oh, it's going to save hundreds of thousands of dollars. It's going to be so much cheaper. And at this stage that we're at, it's still early. It's really not that much cost savings. But as Matt was pointing out earlier, we can provide a better product, that's more durable, more maintenance free, longer lasting, and more interesting design palette, and be able to design specifically for needs, and I'll get into those kind of things a bit later. And even if we do that at the same price as conventional construction, in my mind, that's still a success. But hopefully, as we do this more and more, we can make it more cost effective. So without too much more talking, let me share my screen here. So this is the construction document package for the wildfire restoration house that we did. Just a quick description of the design. It's a very simple design concept. Essentially, the 3D printed portion is the white walls that you see here on the two sides, the bookends. It's a 3-bedroom house, master bedroom on one side, 2 bedrooms on the other end, 1,200 square feet, 2 bath. And then essentially the 3D printed walls become like the skin of the house, and they become like the formwork for the reinforced concrete pilaster. So these gray elements that are here in the exploded axon, are the reinforced concrete pilasters. And I'll show in the floor plan here coming up where those land in the plan. And then that's capped with just a linear beam that runs across the two sides. And then it's just a regular wood truss roof system that sits on top of it. So we really tried to, especially because this is the first one, we tried to keep this very simple, very easy to digest for the building department, so it's nothing too complex in terms of the structure. So in terms of the package, it's a regular architectural package with plan sections, elevations, notes, details. We have our structural package because it is a concrete structure. And then we have our energy code calculations. And the energy code and the energy report and analysis was a challenge because it's not, the 3D printed wall is not one of the options on the drop-down menu in that program. And we have an energy code consultant that really did a great job working through that for us and taking standard wall systems and using similarities, being able to create essentially a custom wall system. And our reinforced concrete pilasters are 10 inches wide by 14 inches long. So that means that we had a 10-inch wide cavity. So it's a very thick wall. And as we, again, do this more and more, I think we'll be able to make that wall assembly thinner. But the benefit is we get lots of insulation inside that wall. So we have a very high performing wall system, wall assembly, which again, especially up here in Redding where the climate variation, the temperature variation is so wide ranging. It's great to be able to provide this kind of well insulated product for them. So I'm gonna jump down to the floor plan. Again, typical notes and things that we have that you would see in your construction document package. Let me zoom in here on our wall so you can get a sense of that wall. So here you see that thicker exterior wall system. The squares, rectangles are the reinforced concrete pilasters, and the beam is running across the top there. And we recess the beam up into the wood truss in order to make that disappear and really make the roof look like it's essentially just sitting on the concrete walls. Then as we go into the interior, we have just a typical 8-inch pipe shaft wall where we have plumbing, and then 6-inch walls for typical walls. And the printed wall is 2 inches thick. So you can see here that dark heavy line is that is the toolpath line. And I'll show you next our toolpath model that we create that then goes into the 3D printer. And it's different if you have any experience with 3D printing. You have to create a volume in order for the 3D printer to print it. The 3D concrete printing is different, where it reads a line. It has the toolpath wants to follow a path essentially. So that black line is its path. And the thin line is the edge of the concrete. So you see the 2 inches. So then we have at the 6-inch wall, we have a 2-inch cavity here with nothing inside because the wall can stand up by itself. We have, we use simple wire bracing that are just laid down every few layers in order to tie the concrete together. Once the concrete sets for a few hours, it is super strong. It's not going anywhere. But just to make sure that the concrete doesn't move as it's getting layered, it's tied together with just simple metal wiring. This is a little detail here at the door jamb because when it prints, the tightest radius that we can do with the printer is 1 inch on the inside, and then again it's a 2-inch thick concrete element. So the outside curve is 3 inches. So we can't put a door jamb against that curve. So we made these little elements to have a flat portion to nail the door jamb to. The contractor liked that detail. It made it simpler for installation. And in the end, too, visually, it's kind of nice to have this accentuated door jamb or door threshold. I think I didn't mention it when we were looking at the 3D diagram, but in the middle, so in that 3D diagram from the beginning, these were the two white boxes on the sides where the bedrooms are, and then we have the organic walls in the middle. And we did that just to, again, to kind of play with this with the printer and show off what it can do. But architecturally and contextually, we're building these in Reading, and if you've been to Reading, the trees here are really beautiful and distinctive. And so, and now with the WUI requirements, where you can't really have trees, so close to the house anymore, I thought it would be a nice detail to have these organic walls that kind of reflect the like it's like a grove of trees into the architectural design. And we can come back to questions maybe at the end and kind of go through this quickly, and I'm probably skipping over something, so feel free to ask me questions at the end. We've got our typical roof plan with the roof attic vents. The MEP drawing here, I wanted to point out how we get this question a lot. How do you do the outlets? How do you do the light switches? And in the end, it's quite simple. And I've got a photo. I'll show some construction photos at the end. They just set a box into the as the printer is going along. They set a block out wherever there was going to be an outlet. And we played around with the idea because you can control the 3D printer to stop at a certain point and then have a gap and then start again. But the kind of tediousness of that we felt like was too much, and it was better just to have the guy on site be able to make that decision following the plan drawing, but be able to adjust it. So even though we're doing 3D printing, it's not replacing people, the workers on site. We still need the workers on site, the specialists, who know exactly where things need to go, and be able to work with the tool as part of the process. And then it's just a typical drywall ceiling that's attached to the roof trusses, and then we got downlights in that ceiling. So fairly simple. And then our typical elevations. We did some well, we tried to push the envelope a little bit with our window detail, and we've got some photos to show that, and I'll show that in the detail too, where we, rather than having, we've got this 14-inch thick wall, and rather than having this big window sill and frame wrapping all the way around the window, we inset right here underneath the window and on the sides, so that we didn't need any additional windowsill. The window can set right on top of that, the concrete, and be attached top and bottom and sides. And we learned through the process, though, that because of the way that the 3D printer works, it prints out. It's like when it prints, and you could see that in the photo and the videos, that it's like like squeezing out toothpaste. It kind of bulges out. It's not so clean and sharp, but you can use flaps on the side of that in order to get a really clean, sharp finish. And actually, the photos that Matt was showing from the Woodbury project, they used the flaps, and it turned out really nice and clean. And we didn't use the flaps on the Wildfire Restoration House because of this window detail. So they've talked me into revising that window detail to not be, because it's angled, the flaps would cut into the concrete as it's going along, and wouldn't look so nice. So in the end, we've just set the whole thing in. So rather than sloping up to meet this the window, we just set it in here, so we can still achieve the same thing without needing the big windowsill. So it's all still a work in progress, and live and learn. Typical elevations, section drawings. I'll zoom in on some of these here. You can see the the roof truss and how we buried the beam into the roof truss, just to let the concrete walls really be expressive. Here's the enlarged wall sections, and it was really important, I think, to think about, you know, those interface points where the printed portion of the wall meets the you know, poured in place foundation, or where it meets the roof structure that's going to be set by manual labor. And we spent a lot of time working through those details, and in the end, there was still a lot of issues on site that we learned and had to work through. But it just, even though we've got the 3D printer, you know, it's so important to have these enlarged wall sections and think through those conditions. So here you can see that wall detail, the old wall detail where it slopes up to meet the window. We did it on both sides, and then the typical wall section, the 14-inch wall section, then where we have the floor to ceiling windows, and the typical cantilevered roof truss. In large details, the windows and doors, we attach them right to the concrete. Again, we were wrestling with how much tolerance to give ourselves, you know, because the printed wall is based completely on my toolpath model, which I'll show you here in a moment, which is kind of exciting as the architect. You know, a lot of times we do the drawings, then we give it to the contractor, and we don't know exactly how they're going to make the wall or where the wall is going to go, or they call us out to the field and it's in the wrong spot. But it's great, but it's also a bit nerve-wracking because we, you know, if the wall is in the wrong spot, it's now our fault, and they can't move it very easily. So it is added stress and added responsibility, but I think it's great, you know, that we get to control that and work with the contractor to consider things like that, how much tolerance to give for windows. In the end, I think we only had a 1/4 of an inch tolerance, and it was totally fine because the print, you know, is very precise, and it looks quite clean in the final condition, not having to have an additional trim going around those windows, and they just caulked it right to it. And that's what's great too about this process of working together with Emergent 3D's team. They have a licensed contractor on their team, and I really see this as a design build process. You know, I couldn't, as an architect, I couldn't do this design completely on my own. And I've learned a lot from the construction team from Emergent, and continue to learn. I mean, that's part of this whole process, is to continue to learn and make this better. And then we just did some enlarged interior details, showing that the door jamb at those different wall conditions. I'm not going to spend too much time on the structural package. Todd Keeman is our structural engineer. He's based in Sacramento. He's a great structural engineer, and he's been with us from the beginning. Let me see if I can get his. Yeah, they're response structural engineers in Sacramento, and he's really, I give a lot of credit to him to help us get through the building department. Just to talk about that for a second. The building department review in the city of Reading, it took a long time. You saw that on my title block. There were five reviews back and forth. And on the architectural side, there wasn't anything too specific about the 3D printing. It was just mainly typical, you know, architectural questions and comments. But they really dug into the structural design, and Todd used to work in Reading, and so he knew a lot of the people in the building department and was able to meet with them face to face. They had a lot of meetings, adjusted the drawings, and did a great job to design something that was really made the city of Reading comfortable, because they are the first building department to approve this. Since then, we've, you know, as Matt was saying, we've gotten this approved in 3 other jurisdictions, and it was very quick and straightforward because the city of Reading had already gone through the process, and those notes and record was documented for other jurisdictions to be able to refer to. Didn't want to just show this. I think this is a nice section detailed, that's a bit more detailed than mine, that shows the 2 wall conditions. where we have the insulated wall where there's no pilaster and the beam going over the top. And then where we have the reinforced concrete pilaster and the beam is attaching to that. And very large foundations. It's a very durable and strong building, probably over designed again because it's the first one, but it's a lot of incredible structural engineering with this. And then I'm going to show you some construction photos, but before that, I just like to show what we were wanting it to look like. As you all know, when things are in construction, it's never looks exactly as you're wanting it, and you're hoping that it does turn out. And we think that it, with the capability of the finishes, that we will be able to achieve these things. So our design intent for this one is to do a smooth finish. We're going to plaster the walls on the two sides, the two white sides, and then let the middle organic walls remain fairly a little bit rough and textured to show that the history or the nature of the material, to expose that in certain places. And these are renderings, design intent renderings of the wildfire restoration house. So I'm going to stop share, and then I have to reshare the photos. Let's look at these. And Matt had shown a few of these already, but I've got a few more interior photos that may be interesting. So this is the outside. This was the first one, as Matt had said, and so it was very rough. They've already started to plaster it, and they're not finished plastering it. There was some places where the wall texture had come out 1/4 of an inch or 1/2 an inch. Again, with as they're trying to get used to how the machine works. So this one is a bit rougher, and I was saying there that we're going to leave these organic walls textured because it was so textured, it was so rough. We did have to plaster it, but we're hoping as we do this on the 3rd or 4th one, we'll be able to leave those fairly unplastered, unfinished. There we go. You can kind of see that inset window detail, how that curves in order to meet the window. We have no additional frame around that. There's the window. You can see how the light hits the curved wall. Still a ways to go with it. We're going to plaster the ceilings here, plaster it smooth. You can see how rough that is. But again, this was the first one. As we're doing this more, it's getting much smoother and cleaner. And the window detail on the interior. Here you can see one of the outlets blocked out. They just set the outlet box right in as the printer was going. Another outlet there, and then getting some curved walls on the interior, so you can see how the trusses run across, and we just have the ducting running up through the ceiling there. So I see we're running short on time. Let's see. I may just skip the church. Maybe I'll just quickly show that. We need to wrap this up in a couple minutes. Go back. So maybe just one thing to point out, the exciting thing with this, for this church project that we're doing is that using the 3D printer, we can print shapes into the walls. And so the idea is that we would print the acoustical, the correct acoustical deflective shape on the interior inside the sanctuary and the classrooms. We carried that shape onto the outside as well in order to kind of create this sort of curtain-like appearance on the exterior. But here you can see, when you look into the sanctuary, you see that, and it's a tighter radius we worked with an acoustical engineer, David Harvey, who's a brilliant acoustical engineer. Honored that he took on this small project with us, and he gave us the right shape in order to create acoustical deflection for the sound to bounce out. And then we had Acousta deck on the ceiling, and with the chairs, and we'll have some drapes at key locations in order to properly absorb the sound. And he did a full acoustical analysis and report and study in order to confirm those shapes. And I'll just quickly show the floor plan of this one. And so again, this one is building department approved in Tehama County. We're quite excited about that. As with all projects, there's a bit of a budget issue or process that they're going through right now. So they haven't started construction yet. But it's not because of the 3D printing that's adding extra cost. You know, we're able to do these kind of things with the shapes of the walls, and it's not adding additional cost. You know, we've had to add some additional windows, you know, and those kind of things are adding the cost. It's not the concrete walls. And then lastly, just a really quick, this is what's on the boards right now. We're working on some new house designs in Paradise to help rebuild the town. It's a huge problem there right now. If you've been there recently, it's just there's really there's a lot of need for new housing solutions there. So we've done three house designs, 3 floor plans, a small, medium, and a large. And we gave each one a different rooftop. Each one has a different haircut in order to try to create variety, you know, so that it doesn't feel like it's this whole city of not that we're going to rebuild the whole city, but just, you know, ideally, if we can rebuild a bunch of these, you know, that they all don't look the same. And one thing I wanted to mention as I wrap this up is just the finish options, you know, like people, we always, you know, like to use the natural materials, stones, woods, and, you know, that adds cost to the project. And with a 3D printer, it'd be a shame to 3D print the walls and then add a cladding on top of it. So what's exciting to me is to think about what we can do with a 3D printer to create texture. And, you know, when you look at some of these images, you know, like how the texture, you know, it's, you know, I think it's the texture that people like, not necessarily just the material. And so being able to create that texture with a 3D print head, or, you know, after the fact with a trowel to trowel the material in order to give it a texture. And then also with colors too. There's some pretty exciting things that other 3D printing companies are doing where they're mixing colors into the walls, where you get this kind of like rammed earth kind of appearance. Or even if we just do one color and that color is through and through, you don't have to worry about painting. That seems quite exciting. So I should wrap it up. I think I went 3 minutes over. Apologies. Shall we switch to questions now?
Yeah, thank you so much, Matthew and Benjamin. Let's go ahead and open up the floor to questions. And I believe there's been a few questions in the chat as well for you guys.
I saw a bunch popping up, and when I was on this section, so I'll leave it here.
Well, why don't I just start? The first question I had was, while you were talking about the insulation in there, I was wondering, what was the R value you were able to achieve in the prototype home?
So we, at the insulated wall portion, I mean, we have to be a little careful how to say it. It sounds nicer than it is. Like at the 10-inch portion, it's over R40. But when you do the blended, the blended number, where you take out the pilasters, then it's about an R28.
Okay. Let's see. What material is in that 1/4-inch soffit panel? Letitia asked this question. Letitia, do you know what soffit panel she's talking about?
In the ceiling?
Yeah,
missing?
when I saw the detail, some wall detail, it calls out
Uh-huh.
a 1/4 inch soffit panel. I'm just curious what it is.
Yeah, and I think in the end, what we're doing there, we're not leaving it as a finished panel. We'll just have a plywood panel, and there's stuccoing over it.
Okay.
So what kind of access to the property is needed for the printer to work, and what sort of support is also needed for the printer due to its weight at the property?
It's a good question. Um, yeah, Matt, do you want to talk about that in terms of the how the printer is set up on site?
Sure. So we need about a 5-inch clearance on either of the slab in order to for the 3D printer, depending on how much of an offset. With our projects here, we actually incorporated the towers into a sidewalk that was going to be used after the fact, so we can certainly design to that. The 3D printing is the ADUs. We've gotten a lot of questions on, would ADUs be a good, and it depends if we have direct access back, say it's in a backyard or that type of thing. The printer is modular, so we can, pack it down. But if we can't get a telehandler or reach it with a crane, then that makes it prohibitive for us to do like a backyard ADU or that type of thing. So, but the modular nature of the 3D printer does open those the scale and size of the project. And it have to be a case by case basis, but we need direct access to where it's going to be.
So is that what that sidewalk is that we're seeing?
Exactly.
Correct.
Yeah. And there's another one on the other side. So it does need some space around it in order to set that up.
All right. Do you think 3D printing will work on a hillside site?
It's a good question. Yes, the towers, the four legs or 6 legs that it sits on you can have them at different heights. So it can work on a slope, but it's typically simpler. We've been looking at a few projects and starting to work on the design where it's on a terrace site, and we've been finding that it's simpler to just level it out in order to set it up. But it is possible to have it on sloped ground where the printer is sort of straddling 2 different elevations.
And with that, can you print multiple stories?
Yes, good question. Yes, we can go up to 25 feet. So that church project I was showing, that those walls are 24 feet high. And so we haven't worked yet on a 2-story project, but and there's a few that have been done here in the US, like on the house scale. But there's some larger 2-story buildings, multifamily type buildings in Europe that are happening. And this, I don't if Matt mentioned it at the beginning about the machine that we use is from Kobod. They're a Danish company, and it's been a great collaboration with them. Because they've been doing this longer than we have, and so we learn a lot of things from them, and they're a bit of a step ahead of us.
When are the doors and windows inserted, and are those wood headers on top?
That's a good question. That was a mistake. Those headers, right? Is that what someone was asking about? That the window should go all the way to the top. But so the windows are added after as with a typical construction, the walls go up, the roof goes on, and then the windows enclose it. So it's fairly traditional in that sense.
Can you elaborate on the city or jurisdiction approval process and challenges other than structural? I mean, did you need to submit a number of alternative means and methods for review and approval by the building official?
It's a great question, and we thought we were going to have to, but we didn't. On the architecture side, on the structure side, there was a couple tests that were required of the durability of the concrete, and they were able to print some small pieces and do some lab testing on that. They were able to also get some existing data that was already on hand from other projects in Europe that satisfied what the building department needed. So I think the biggest challenge with the building department was just because it was new, and the city of Reading knew that they were the first ones approving it. And so, but it's a great credit to them, to the city of Reading, to be willing to review it and go through that process with us. And but it's like anything, when you're the first one going through it, you're going to really get a lot of scrutiny, and every detail gets checked. But again, on the architectural side, again, because we were using fairly straightforward conventional approaches, it was just the skin that was different. And I didn't mention this, but the skin, we sealed everything with a water sealer, inside and out, just to make sure nothing gets into that cavity. And they were very careful to make sure to protect the cavity as well before sealing it in.
And I think we're understanding that with the wire bracing, that the only wire bracing that's there is to keep the concrete from moving, that it's really they're unreinforced concrete walls because you have the pilasters in between for the structure.
That's right.
Okay. Jason wants to know, what would be the price range for a type 1 story 3,000 square foot or 2-story 6,000 square foot, understanding initial cost versus life cycle cost? That sounds like an entire hour long session, Jason.
If you'd like to help us do that analysis, give me a call.
Yeah, I mean, it's a great question, but
it's a good question.
So,
yeah.
Well, on a high level, can you answer that?
So I got to clarify. So just a quick nugget is this: you said there's a 3,000 square foot model and a 3,000 square foot 1-story, or 2,000 or 6,000 square foot 2-story. Just what's a general unit cost would someone expect at this point?
For the printed portion, or for just the whole house?
Overall project. You said it's pretty comparable to normal construction these days. So what would that range be? Range is okay.
I think it really would depend on the location. I mean, what we're finding here in Reading, Shasta County, is like $350 a square foot.
Okay. Is it possible to have change orders? Say if you need to relocate an electrical outlet or relocate an interior wall?
Great architect question. Something we try to do is to foresee that, like on this house, all the walls are printed, and I didn't, let's see, I don't think I have a photo of it, but on the wet walls, what we ended up doing is leaving portions, like where the plumbing is going in for the shower, or for the vanity, or for the toilet. We left parts of the wall open, not printed. And then they came back in and just added something. Actually, where the vanity went, we just added a full length mirror in order to cover it up. But they ended up finishing the wall over it. That way, if in case there's a problem later in wherever there's plumbing in the wall, or in places where we think they may need to renovate later, we kept those walls where you could easily access the pipes. And what we're doing in our future designs too is to try to, like they always teach us in architecture school, to put the wet walls all together, and then we're not 3D printing those, to just leave those as conventionally framed, because those are the locations too that people like to renovate and redo in 10 or 20 years. And so just helps make it easier, or if there's a pipe that breaks, they can get in there easier.
Okay. All right. This is our last question for the session, and it's a good one. Has any embodied carbon studies been done compared to conventional stick-built structures?
That's a great question. We haven't done one, I've been looking. That's in my notes to try to find some good data. We were working with CEMEX, the concrete company, and they've got great R&D people in Switzerland that we've been talking with, and there's all kinds of innovative ideas about how to make concrete more sustainable. You know, I mean, because concrete's not really the most sustainable material, but we can't really get rid of concrete. Concrete's always going to be around. It's a useful material. So how can we make it, you know, more sustainable is what we're trying to do. And we don't have any conclusions on that yet. And we haven't tried that out in a unique way yet, but that's on our radar to try that.
All right. Well, thank you so much, Matthew and Benjamin, for presenting this exciting new technology for us. I think all of us architects want to learn more about it. And I personally hope this is less of a fad and more of a direct change in the future. Even if it's not concrete, maybe we're looking at other materials to 3D print. But it seems as though this is, it's happening with our models, our architectural models. Very few people are building them by hand, and more are doing them in 3D printing. So now we're looking at a grander scale. You guys have any closing comments you want to add?
Thank you for having us. It was an honor being with you today.
Yes, thank you very much.